Assalamu alaikum everyone. Today inshallah we will start our next now we have finished C++ programming, and the next target is to discover and practice on another software, another programming language environment, which is PC data acquisition controller software. Okay, this is a specialized software, okay, that we have designed for our data acquisition environment. You have already seen in the lab that we have a data acquisition hardware where we have certain number of inputs, certain number of outputs. We can interface all kind of hardware with our existing data acquisition hardware. Okay, we have a main card, this one in the lab, on which we have also done the interfacing and programming in C++ language. So the same environment I am talking about. So we have done one way to program our input and output in our data acquisition using the C++, which is a high level language. Now we will go to the next environment, which is PC DACS controller software. It's like an application based software, okay, like the way they are used in the actual industrial environment. Okay, it is we just try to teach you the way you will see the things in the industry, but that software is specific to our hardware. Okay, the hardware that we have, this is specific to that hardware, this software. Okay, so you need to and we will inshallah discuss this programming today, PC DACS controller software. Now for the address selection, I will not go in that detail because it is just, you can read yourself how the addressing system works. Okay, it is very simple. Okay, I don't need to, we have discussed many times. Okay, I don't need to spend time on it. The only thing you should know that our main card, the main card that we have in the lab, it has an address 1. Okay, our main card has address 1, while we can connect up to 255 such cards to our in the system. Okay, it is only, we have only one card, and that card is as address 1. So but we can extend it up to 255 cards, because we have 8-bit addresses, 8-bit address. Okay, so the only thing we need, you can just go through this one yourself. Okay, but just only you should know that our address for the card that we are using in the lab, okay, our address is 1. Okay, that we will use. Now this is the CMC controller. When you will go in the lab, you will see this CMC controller, DACS controller in the lab. Okay, and this controller is the one where we will use this environment, okay, to do the programming. Okay, DACS controller to do the programming, inshallah. So once you will click on it, what you will see, okay, when we will double click on it, what you will see, this is the main menu. First of all, understand. So here on the right side, first of all, we have 3 things. We have a software indication lamp, okay, which is like we are there are 2 ways. Either we can use this software to interface with our hardware, okay, or internally also. For example, I write a program, okay, to control my input and output, but before interfacing it or writing it to the actual input and output, I want to check that my logic is working properly or not. So that one I can check using the input and output provided within the software itself. So this is the software indication lamp that mimics like an output, okay, that resembles an output, and these are the push buttons that resembles as inputs. Okay, so whatever the logic, I will provide the program here before before running the program on my actual input and output, what I can do, I can check the logic here within this environment just to ensure that whatever the program I have written, it is working properly, and then I can just download it to the, I can run it on the main hardware. Okay. Now how we write in the program, we write by the push button P and indication lamp M. So P and M, P, M are the symbols that are used. So we have starting from here, it is P0, the addresses are P0 to P7, it is M0 to M7, remember. Okay, this one represent P0 and P1, P2 up to P7, M0, M1, M2 to M7. Okay, these are the registers. Okay, registers are what? Memory location. Okay, registers are memory location inside your memory, D0, D1, D2, D3, D4, D5 up to D7. Okay, D0 to D7 we have different memory location where we can store some certain values. They are memory location registers. Now if you see the programming, this is your programming area. So initiation start, initiation end. Okay, whatever you will write in the middle, okay, that will be scanned by timer, scanned only one time. Okay, that will be done only one time. After main program begin, you write the program here, that will be the continuously scanned. Okay, so whatever you write here, you want to write only once, to be scanned only once, you will write here. Okay, okay, it will be scanned only once in the beginning, and whatever you will write here, it will be continuously scanning. Okay, because there is a forever loop. Okay, here. Okay, so the program recalls again and again and again and again, so with the forever loop. So in this main program area, this area is scanned continuously, this area is scanned only once. Okay, here there are the two buttons. Okay, when you will press here, it will to start the program, and this is to stop the program. Okay, so this is just the main environment. Okay, now let's go and watch how do we do the programming. So for example, we start with this typical ladder diagram on the PLC. I don't need to discuss this one. We know that it's a push button. If I will press this one, okay, the circuit will complete and the lamp will be on, and so on. Okay, now I want to write a program for this ladder diagram in this environment. Okay, so now we have a push button. First of all, we have a push button P and we have a lamp. Okay, so I want what, when I press this one, now it is a normally open, so when I press this one, the lamp should go on, and it is normally open, by the way. Okay, when I don't press it, it will be off. Okay, it is simple. So how will I write the program? How will I write this program? Okay, we use a load command. Okay, here load command is like what, when you say load P0, okay, means it is pressed. Okay, it becomes 1. So means you click. If we click on P0, it becomes true and holds the value 1. It means it is loaded. This input is loaded. Okay, push button input is loaded. When it is not clicked or not loaded, it holds the value 0, false. Okay, so we use a word which is called load. Okay, load, to load the input. Okay, like we press the push button. Okay, so here when it is loaded, it becomes pressed. This is a press, means you press the push button, and this means you have not pressed the push button. Okay, so this is how it works. So very simple. What I will write the program, load P0 means if this P0 is pressed, means you will bring your cursor here and you will click, okay, with the mouse. When you click with the mouse, out M0, okay, means it is telling, the other command is telling that this output M0 should be on, okay, with this click. Okay, so it is same like, see this diagram, that you press this push button, this lamp is on. So similarly here, load means you press this push button, and out M0 means this lamp should be on. So we have two commands, load, okay, to activate the input, okay, to activate the push button, and out command is to enable the lamp accordingly. So it's a very simple command, load P0, out M0. Okay, at this moment, when it is like this, it means you have not pressed. Okay, so this situation is 0, false. Okay, not pressed. See, not pressed. Okay, not pressed. When you will press here, it will become like this. It will become like this. It means it is pressed. It becomes true. Okay, so when you will press this one, it will become true. This input will become like this, and you have written P0. So I cannot press this one because it is P7. Okay, or I cannot press this one. It is P1. Okay, so load P0 means I will press only this. When I press this one, I mean, what do you call it? The input. Okay, push button input. Okay, this out M0 means this output will be on. This is M1, this is M2. I told you these are the addresses. Okay, up to M7. So I press this one, this output is on M0. Okay, this is the way it works. So you can just fill all these things, is no problem. Similarly here, now this one situation is when you have a normally open push button. It can be normally closed as well. Okay, what is normally closed? Normally closed is what? If this is not pressed, if it is normally closed, okay, I will not draw it, but you know, if it is not pressed, if I say normally close, okay, means I make a normally close here. Okay, so it means that if it is not pressed, it is on. When you press it, it will be open, right? Okay, this is how it works. So now it is normally open push button. So if it is normally closed push button, it will be simply opposite, and you will have a ladder diagram. You will have just only a normally closed switch here. Okay, a symbol here. So how we will write in the program, it will be that one is load P0 for normally open, and here the opposite logic will be load not. Okay, load not means if it is not pressed, okay, it is normally closed. It is not pressed, so lamp is on. So here see, it is not pressed, it is on. When I will press it, okay, it will just change the status. Why? Because the lamp will be off. Okay, so this is the way it works. Okay, normally open and normally close push buttons. So, and you know how we just do the normally close. It will be just close push button, and here it will be this close also. Okay, and similarly, so we have load not means now this switch. Load not means this switch becomes like a normally closed switch. Okay, I can write the same thing like this: load P0 not out M0. So it is same thing. Okay, but now it remains the push button, but in the middle I add a logic not. Okay, not. Okay, so not out, and so it means when it is not it is pressed. Okay, then output should not be on. When it is not pressed, output should be on. So I can write the same logic. Okay, this one logic I can write this way as well. Okay, this way as well, same thing. Okay, it will be like a normally closed push button. Okay, so load P0, although this one is normally open, but I write not out M0, so it will behave like a normally closed push button. Okay, now this one is for, as I said, P and M. We are writing P and M. P and M are the internal inputs and output. Okay, internal push buttons and internal lamps. Okay, for within the software. But this data acquisition software, I can also write the program for our hardware. How I will write? I will use this way. Very important. First of all, for the input I and output O. Input I, output O. Input I, output O. Then I will write the large bracket. Okay, and then I will write the address 1. Okay, and then the input number 3 comma 3. Okay, means the input number 3. Now for example, if you remember in your hardware, so 1 is the address. First of all, 1 is the address for our card. Okay, now in the card, if you remember that we have Okay, so in the card we have lamps, LEDs. Okay, 1 2 3 4 5 6 7 8. Okay, so here what is the address for these outputs? Okay, so this one is from here, output O 1 0 means output. This is card address and this is the 0 address. Okay, similarly output okay, let me just write with a different one so that you guys can understand. Okay, so we have a okay, we have a output O. Okay, I will write card address because this whole card that we use hardware, it has the address 1 and output number 0. Similarly this one will be output 1 1. Okay, and so on, and the last one will be what? Output card address, but this is the output number 7. So these are the LEDs on your hardware that we have in the lab. Okay, these are the LEDs output. We will not need to write. Okay, so now you know, understand this one. Okay, output. And what about the inputs? Now we have push button inputs, right? We have 5 push button inputs. So we have push button inputs. Okay, so the input, I will write this, the first one, the same. It is the I will write I. Card address 1 and input is 0. Here it start from down, here it start from up. Okay, and then you have I. Card address will remain 1 and input number 1. And it will go up to input number 4. 1 so input 0, input 1, input 2, 3 up to 4. Okay, so we have 5 inputs. We know we have 5 inputs and we have 8 outputs. Okay, O0 to O10 to O17, 1 is the card address, as I said, card address, and I10 to I14. Okay, 1 is the card address and these are the input number. These are the push buttons. Okay, this is our hardware. Okay, you should know these addresses, how these addresses are. Okay, so now let's go back. It is telling you load I13 means if you press input number 3. Now where is the input number 3? My input number 3 is this one. Okay, I0, I1, I2, I3 means if I press this input, okay, if I press this input push button here, okay, in your hardware, okay, if you press this one, what will happen? Load M0. So you will see the software lamp will be on, and when load M0 means if this software lamp is on, out O15. So O15 is what? 1 2 3 4 5. Okay, so this one will be on. Okay, so when you press this input, this is on. Okay, this is how it works. So first of all, you press this input, okay, on the board, this push button I13, which is from up to down 13. Okay, and this number, okay, you can, while you will be practicing in the lab, you can change the input. Okay, it is up to you, it's no problem. Okay, don't worry, you can change the input depending upon which input is working. Okay, so when you press this one, then first of all you will see in the you will see in your software, this lamp M0 will be on. Okay, and then when M0 is on, output will be on. Okay, output on the board will be on. So here now I am not using the push buttons inside the software. Okay, I am not using push button P. Okay, there is no P. I am using my actual hardware. Okay, so now I can interface. And how I am interfacing? Because I am providing address 1. Okay, address 1. So address 1, because like this card is at address number 1, so with the address 1 I can connect to the inputs and outputs. Okay, so you can just do, no need for this one. Okay, no need to for the addressing anything, just leave it. This no point. Okay, now here sometime we have the AND instructions. How AND instruction work, we all know. Okay, AND instruction is well, this is the AND instruction, right? Okay, so how AND work? P0 and P, so very simple. Load P0 and P1 out of 0. So you will press P0, it will not be on unless you press both. See, now both are pressed, both are true, right? Okay, this means this is 1, this is 1, both are pressed, both are true. Okay, must be true to activate M0. Similarly, we have this one is just load not P0 and P1 out M0. So now this one is normally closed, this one is normally open. Okay, so the same thing, you can just watch how can it would be. So this one is, if it is not pressed, this one is pressed, then only output M0 will be on, this M0 will be on. Okay, so two conditions. Okay, so this one is what now, or. Okay, or we will use load M0 P0 or command. We have or command P1. So this programming of this controller, DACS controller software is very simple. Is very simple. Okay, it's like just only a very easy human language. Okay, just only to give you an idea that how these data acquisition softwares they are provided. Okay, similarly here, load not P0 or not P1, so both are not. Okay, both are normally closed. Okay, okay, so any one of them is normally closed, any one of them is normally closed, both output is on. If both are open, then only it will be this one, both are activated, then only this will be off. Okay, similarly you can see that load input 3 or input 4. Now I am actually communicating this one interfacing is with the actual output. Okay, so this program, for example, wherever you have P using the internal input and output, when you have I and O, means you are using external input and output. Okay, so you can just go through, it's not a big deal. Similarly you have different logics. Okay, you can have this logic means what, P1 or P2, and this OR logic will be AND with P0. Okay, so AND P1 or P2. Okay, so P1 or P2 ANDed with P0. Okay, and you can find out how this works. This is also very simple. Okay, this is what P0 and P1 or P0 and P2. Okay, so this one is simple. Okay, you can just write down the logic same way. Now here we are using like we use M0, M1 up to M0 to M7, right? We also have other memory location. We can use M10, M20. Like you remember in the our PLC also we use the memory location, right? Okay, memory bits. The same way you can use the memory bits, okay, M10, M20 for different logics. Okay, so I am using these two inputs, 2 and 3, and whatever the output I use M10. Now this M10 is not visible here. Why? Because these software lamps are only from 0 to 7. So it is simply an internal memory location M10. Okay, so it will save the logic there. Then it will and of these two inputs 2 and 4, it will save the logic in M20. Okay, and then it will load M10 or M20. It will check these two logics, okay, and output M0. So then it will control the software lamp M0 here inside. So you can use other memory location also, which are internal memory location, to control some logic. Okay, M10, M20, which are not visible. Okay, usually we use the standard M10, M20. Okay, for our programs, and here M0 to M7 are only visible. Okay, now we see the registers. Registers are the memory location that that stores some value. Okay, so as I said to you that this part of the program is only for there is one more also, this one more command, clear memory, we use commonly in this DACS to just clear all the memory. Okay, clear all the memory location M. Okay, M0, when I will say clear all memory, means all M0, M1, M2, M7, M10, M20, all of them will be 0. Okay, remember this one. Register is different. Okay, registers are location that holds the values. Okay, and set M0 means initially the M0 is on. Okay, so this is what it, and 23 is a value which is assigned to D0. 23 is a value which will be assigned to D0. Now this one will be just implemented one time. I have not written any program. What I want, when you press this one, you will see that it will be implemented only once. D0 value will be changed to 23 and M0 will be on. Okay, so this is how we can also the initial values, just to show you that we can just change the initial values, because this part will be just implemented once. Here this part what I will write will be continuously implemented. Okay, now for example, I want to write a program in which I want to this one power of 2. Very simple. I will move 2 to D0 initially. Okay, so now I use move command. For the registers I use move commands. Okay, move command to register to move the values to the register, because it is an analog value. Okay, it is not a true or false. With true false we use load. Okay, load B0, load B1, load I, okay, or out commands. Okay, for the output, load command for the input. When we have the values, decimal values, okay, and because those decimal values are stored in the 8-bit this one registered, so they will be always move command, because they are decimal values. So it is very simple. 2 will be stored into D0, and then you are D2 is D0 to the power D1. Okay, so D0 to the power D1 means what? It means, what is D0? 2. So 2 to the power, it is actually 2 to the power D1. Okay, now when I will change D1, okay, D1 1, so it will become 2 to the power 1, okay, D1 2 to the power 2, D1 3 2 to the power 3, and so on. So I will just change the value from here up and down. Okay, and I can check the values of D2. D2 will change. Okay, D2 will change. So I can control the values of the registers from here. They are mainly used for they can also be used for the arithmetic operation, plus minus. You can do these kind of operations. Like initial value of D0 is 1, initial value of D1 is 10. Okay, these are fixed now. What is D2? D0 plus D1, D1 plus 100. Okay, so you can then change the value, and you can see different combinations. Okay, now you can change the values also, and you can change different combinations. Similarly for the addition, similarly for subtraction. Now here there is one command bit, this one flag, which is called underflow indication bit. Load this F20 bit. Okay, let F20 bit is an underflow indication bit. It happens when you, let's say you are doing subtraction and the value will be minus. What will happen? This bit will be on, F20 bit will be on. So you can just see the indication. This if load F20 means if the result become negative, out M0 will be on. So means when M0 is on means your result is D3 is negative, has become negative. Clear? Okay, so this is the underflow indication bit, and you can use it to make some output on, so to know that this one is high now. Okay, similarly you have division command, and if you divide by 0, then there is one bit F19. So when you have negative value, okay, result is minus F20. When you divide by 0, because divide by 0 is not possible by mistake, for example, if you divide by 0, then F19 will be on. Okay, and F19 is on, then out M0. So you can just run this command. It is very simple, and you can see what will happen. You can make different values, and let's say you keep one value. Let's say you keep D50, for example. Okay, and then you check the T1 divided by 0. You will see this F19 will be on. It means you have divided by 0, which is not possible. Okay, so this is the first program. And then we have second program, which is the same thing we can use for the greater and smaller. We can compare different values. We can run the command. We can run this value. So initially we have stored the value, then we are comparing, and accordingly we are controlling the software lamps M0 to M7. Same command. This one also program is very simple. The registers. Yeah, now here it is just a very interesting. Okay, move D00. So D0 value is 0. Then if I write D1 equals to not D0, what will happen? They will be just opposite. So in this one is 65535 because it is 16. Sorry, it is 16-bit register. Okay, so when you see 2 to the power 16, it is not 8-bit. I am wrong. It is 16-bit register. Okay, so 2 to the power 16 is actually 6 5 5 3 5. Okay, so it is 16-bit register. So now if I will have 1, it will become 65534. If it is 2, 65535. If I make it 65535, it will become 0. If I will make 65534, it will become 1. Okay, because they are not command. Okay, so we can, maximum value is, as I say, it is 16-bit register, so it will be 65535. Yeah, 2 to the power 16 minus 1, because it goes from 0 to this one. Okay, so we have total 65536 values, and it is 2 to the power 16 minus 1, the last one, so 0 to this one. You know this logic. Then we have same thing, load P0, out M0, out M10 means now you are controlling the output also. You have software indication lamp, and you are also controlling the output. Okay, these are the different simple things. And here, very interesting, 128 value you are moving to D0, and from D0 you are taking to output 1. So then your output, at the output, now this analog value will go right. Remember, write all digital command. Now it will not be this one, what you call it, if I use, very simple, if I use out command, it means it is only one location, only one bit, one lamp. Okay, it is only for one lamp. You have 8 lamps, right? Okay, so we have O 1 7 from O 1 0. So if I use like out command is like in C++ set digital channel. So this one out O10 means set digital channel 1. If it is this one, 7 means set digital channel 8. Okay, so it is means you are writing specifically for that particular output. But if you have a move command, here what 128 is going to D0 and 120 from D0 to O1 means 128 value will go to O1. This move command is equivalent to write all digital, means 128 will go to all the output. Now what is 128? 128 I know it is 1 0 0 0 0 0 0 0. So this output will be on. Okay, so it is like if I have a move command, remember if I have a move command, move, and I am writing here like this O1 O1 and we have some value. This one is like write all digital. Okay, you know this command, right? And then you write the values. Okay, here, so this is like the same thing. Okay, move command is same like or like write all digital. Okay, so decimal value will go here. It is different from, this is different from out O. Here it is only one output. Here this value 128 will go to the all the outputs, like write all digital command. Okay, similarly you can check others as well. Increment is increment register, and then it is going to this one. Okay, so the values will be distributed like an analog value is going. Okay, and decimal value I mean is going, and it will be like write all digital. Okay, same thing here. Now there is one thing which is AND pulse 0. What is this AND pulse 0? AND pulse 0 means like a rising edge, rise edge, edge triggered. So means when you have this one, it means you will press 2 times and then you will see the change. When you have a load P0 and pulse 0 means when you press that one. Okay, it is like a edge triggered. If I use P1, I will use pulse 1, P2 pulse 2, and so on. Means it is edge triggered for that particular. And you know edge triggered. What is edge triggered? Edge triggered means it will be, if it is a P push button, means it will be activated as here. Okay, similarly F15 is to for the timer overflow. Okay, so for example set user this one timer 1 500. Okay, so it is a pulse timer. Okay, and when the timer will complete, okay, then pulse this one pulse 0 will this one be on. Okay, and you have load F15, sorry, load F15 bit. Okay, timer control contact bit. So when this timer will complete 500, okay, whatever your 0.5 second counting. Okay, it is 500 is here is 500 millisecond, which is 0.5 second. Okay, so when it will finish counting, this F15 bit will be contact bit will be on. Okay, so this F15 is a pulse counter pulse timer contact bit, pulse timer contact bit, which depends upon the timer value. So when you say set user timer 1 500 means it will start from 500 up to 0, means it is a lapse of 0.5 second delay, and when 0.5 second it will go from 500 to 0. Okay, means it counted 500 millisecond, 0.5 second. This F15 pulse timer contact bit will be on, and then it will check if it is edge triggered, then whatever it will depend. Pulse 0 is that for the edge triggered. Similarly you have other commands, you can just go through and you can check. Okay, so rest of the things inshallah you can just are very easy. Okay, and if you have any further question inshallah while you will be doing in the lab, we can discuss further. Okay my friends, thank you, thanks a lot.